Napoli. I am giving my report about black holes, and here we go. Here's some pictures and whatnot. So the definition of there's three different type of black holes. There's the stellar mass black holes from remains of a collapsed star that are 10 times the mass of the sun. Second, supernova massive black holes, believed to be formed when the universe was very young. Third, miniature black hole, much smaller than the mass of the sun, believed that they could have been formed shortly after the Big Bang. A famous black hole is the Cygnus X1. It was discovered in 1964 during a rocket flight. It was one of the strongest X-ray sources seen from Earth. Estimated to have the mass of 14.8 times the mass of the sun, has been shown to be compact to be any known kind of normal star or other likely objects beside a black hole. The formation of black holes are vary between if they were created after a Big Bang or a collapsed or a massive star has collapsed upon itself. Due to the collapse also causes a supernova or exploding star which blasts a part of the star into space. Sometimes scientists believe that supermassive black holes formed at the same time as the galaxies they are in. The size of the supermassive black holes can be measured in comparison to the mass of the galaxies it is in. Physical properties. The physical properties of black holes could be very simple as having no electronic charge or angular momentum. Birkhofer's theorem says it is only a vacuum solution that is surfacially symmetric. The first equation you see on the page is the Planck unit, which describes the mass of the black hole. The total of the electric charge is Q. Total angular moment is J, and the M is the mass. The second equation is the Schwarzschild radius, which measures the size of the black hole. This relation is exact only for the black hole with zero charge and momentum. Famous scientists that worked on it were Albert Einstein. He created the theory of general relativity, which helps find the mass of the stars, black holes and stars, and the speed of light. And this fellow right here that I cannot pronounce his name, I'll be honest, he came up with a whole bunch of mathematical problems that help us figure out the mass of the supernovas and black holes. Event horizon, as predicted by the general relativity, it is the mass of deformed space-time, such as the way that paths taken by particles behind towards the mass. Deformation becomes so strong there is no path that leads away from the black hole. To observers, clocks near a black hole appear to tick more slowly than those further away from the black hole. The gravitational time dilation, an object falling into a black hole appears to slow down as it approaches the event horizon, taking an infinite time to reach it. the same time, all processes on this slow down, causing emitted light to appear and render the dimmer. This is known as the gravitational redshift. Singularity. Observers falling into a Schwarzschild black hole cannot avoid being carried into the singularity once it crosses the event horizon. It can prolong the experience by accelerating away to slow the descent, but only up to the point after attaining a certain ideal velocity to free fall the rest of the way down. When it reaches the singularity, they are crushed into infinite density, and there's a mass. The mass is added to the total of the black hole before they will have been torn apart by growing tidal forces in the process of something referred as the Noodle effect. Finally, the gravitational collapse. Gravitational collapse is when the collapse stopped by a decent decreasing pressure of the stars constitutes, considering that the matter is exotic denser state. It results of one of the various types of compact stars. Type of compact stars formed depend on the mass of the remnant. The matter left over the outer layer have been blown away. Such form of supernova explosions or by pulsation leading into planetary nebula. This is my works cited. Thank you for watching my video and have a good day.